Hello and good morning, and good afternoon and good evening, depending on where you are in the world you are joining us today. My name is Jeff Lundstrom. On behalf of TA Instruments, I would like to welcome you and thank you for joining us in this webinar. Today's speaker is Dr. Bharath Rajaram. Dr. Rajaram is a product specialist with the Rheology group at TA Instruments with responsibility for University of California, Irvine. Within the product management group, Dr. Rajaram combines his extensive experience in material characterization and feedback from customers to define and guide new products. The title of Bharath's webinar today is Rheology Workflow Automation with TRIOS AutoPilot, Enhanced Measurement Precision and Reduced User Training. During this webinar, you can submit questions, and after you push on that folder, you can see you'll have access to additional materials that you can look through. So with that, I'm going to hand it off to Bharath. Bharath?
Thank you, Jeff, for the introduction. Welcome, everyone, to this webinar on TRIOS AutoPilot, which will help you with rheology workflow automation and enhanced measurement precision. The outline for today's talk about introduce what TRIOS is, talk about TRIOS AutoPilot, and then go into details of what it can do to solve these problems in your lab. We'll then talk about how it works for the end user, how you can use it in your lab using specific customer story examples, and then finally, I'll give an overview of what else you need to know about deploying AutoPilot in your lab. So analytical labs, and what they tell us is, in addition to having reliable analytical instrumentation that gives exceptional sensitivity, one of the top factors that they consider when evaluating an instrument is to be able to pair that with a modern, easy-to-use software package, because this can have a direct impact on the productivity and efficiency within the lab. Some of the top concerns for analytical lab managers and scientists is to be able to assure data uniformity through compliance with standard operating procedures. And oftentimes, this is functional knowledge that an operator accumulates over time. So when a new operator comes on board, there's some potential for misinterpreting the SOP or some deviations from that. And that, in turn, can lead to differences in the data between one shift and the next, or between one operator and the next. So there is a strong desire to codify this knowledge within the instrument software, if possible, to increase compliance with SOPs. But a well-written SOP is just one nuances, and lab managers and supervisors have to strike this balance, right? So they have a need to train operators, but also a need to reduce operator training where possible so that they can now enable walk-up usage of this instrument amongst more operators. And in other cases, organizations might have periodic training for operators on a regular basis. In some cases, this need for additional recurring training comes because, and finally, you want to be able to act on the information that you get from the rheometer, right? So, and you want to take decisions based on that data. Can I ship this product? Did this batch pass? Is there a long-term trend here that, are we gradually moving out of our acceptance conditions? In some cases, we do some of these advanced analysis in third-party software programs. You have to export the data. This introduces additional steps. There was one man, and these limits were written on a Post-it note that was right by the instrument. So to be able to integrate these types of computational analysis directly with the measurement software will go a long way to make the entire process seamless and reduce the possibility of errors for the operator. And AutoPilot delivers on these challenges through primary guiding principles: a simplified interface and guided operation. And together, these two will help to improve data precision. First, a quick introduction to TRIOS software for those of you who might not be familiar with it. TRIOS is an integrated software package that powers instrument control, data collection, and data analysis for thermal analysis and rheology instrumentation from TA. It gives you the option to control multiple instruments with a single PC and software package, and it comes with unlimited licenses and free lifetime upgrades. let's say you take the result from a DSC and a TGA, and you can now overlay the C patterns. And this can be done across the board for all the instruments that TRIOS supports, including DMAs, SDTs, TMAs, and rheometers. Additionally, TRIOS can also offers audit trail and data integrity options with electronic signatures through the optional Guardian package. And we had a great webinar on that earlier this week by Jeff Lundstrom, our software product manager. It's a new premium feature for Rheology within TRIOS, and it's currently available for the HR, X0, and DHR line of rheometers. And it allows you to standardize and streamline operations and decision-making across your entire enterprise, whether it's a quality control lab, central R&D, or a shared analytical lab. AutoPilot was developed with extensive feedback from our end users. So when we talked to them, it told us about the need for a simplified interface and procedures that allowed them to pick up differences between lots in a very sensitive manner. But they were hesitant to roll this out to production sites across the world because of the training that was involved. And AutoPilot, that's where AutoPilot was able to help through the simplified interface and guided operations. And in your lab, you can use AutoPilot to quickly and easily create routines for standard repetitive operations. So let's keep performing tasks and tests. So the TRIOS platform itself is very versatile, it's powerful. It gives users full flexibility for test programming and data analysis and a whole lot more. But then this can add another layer to training programs because new users now have to be trained on the software operation in addition to being trained on the instrument operation. And AutoPilot directly addresses both aspects of these training head-on. On the software front, we present a simplified user interface, shot to the right. It's a very simple interface where the user is presented with an array of icons to choose from. Each of these icons represent a different task that can be launched with a single click without even launching TRIOS. And this is great for new users because it minimizes the training time. They don't have to be trained on the software operation separately. It's very versatile and flexible because now you can customize these icons with different colors or graphics, so it's quick and easy to identify. And it's also possible to separate. This interface is a great example where less is more because the user is only presented with the options that are relevant to the task at hand at any given time. For those that are more comfortable working within the TRIOS interface, AutoPilot scripts can be launched from within TRIOS as well. So you can create a dedicated ribbon, and then you can add AutoPilot buttons for common tasks. So for example, you can do a one-click analysis of all open files, you can create and print reports, and more. So there are different ways in the lab's output is through integrated set of tools for guided operation. Essentially, we walk a new user through every aspect of instrument operation. For example, the video playback capability will allow you to demonstrate proper loading techniques for sample trimming, loading, cleaning. And in rheology testing, loading and trimming are big sources of variation between one operator and the next. And being able to address that and guide new operators will directly have an impact to enhance data precision. The process itself is also designed to be very interactive. During the script, you can add in text-based instructions. You can add dialog boxes that have yes/no options, and each of those could be decision points. You can prompt the user to enter test parameters and sample information. And finally, AutoPilot is designed with the operator's end user's overall experience in mind. So we recognize that in a busy lab, the TA rheometer is just one piece of it, a visual indicator of the progress and the time remaining in a given operation. So this will essentially replace old-fashioned kitchen timers that are still being used in labs. And this timer can be displayed in a full-screen view so that the operator can see it from across the lab, and that helps them to prioritize their tasks appropriately. And if you have any time-sensitive operations, you can use the timer to abort the test and start all over again if the operator does not move to the next step within. And we'll demonstrate each of these application of each of these features in the following slides in the different use cases. And with that, we'll move on to cases where AutoPilot has been deployed in real-world labs. The first example we will look at is a QA/QC lab that tests a wide range of different products. And in this case, the operator just simply launches a script from the one-touch interface. So they could walk up and they could choose to do on any given day a video. So when we start, we always give an overview of what the script does, what geometries are required, and we can then have built-in checks for instrument calibration as well. So if it's within a specified range, we can continue. Otherwise, we can prompt for calibration. And then we can set the test temperature and be followed by with geometry calibration. And this here is demonstrating a case where we use the timer to tell the user where we are with the geometry calibration and process. So once the calibrations are completed, we tell them, the calibration is complete. They click OK, and then we can ask them for sample name information. So this particular script we also log in the operator's initials information. And then we follow that with sample loading and trimming instructions. In this case, we're giving text-based instructions, and the operator is going to go ahead and load the sample on the rheometer right now. And when they click OK, the geometry will be lowered to the trim gap automatically. You can see some changes taking place in the control panel. You then tell them to trim the sample using the appropriate tools. Sources of errors, underfilling when loading the sample or overfilling, and being able to check for that can minimize errors. The test then starts. This test has about 4 different steps in it. It takes about 20 minutes to run. They're all contained within a single procedure file. There's a frequency sweep to start with. It's followed by a strain sweep that goes outside the linear region, and then you will see a time sweep at the end of it. Notice how the TRIOS UI operator down a single path where they are only interacting with the dialog boxes that show up through autopilot. And whenever an autopilot script is in progress, you see the autopilot logo in the lower left, and that indicates that the progress that a script is going on and that the script is controlling the user interface. And this again minimizes any chance where they might change any settings, might change test parameters, and helps to streamline operations across an organization. For example, step 2 has a modulus crossover, and the report is now ready without any additional user input. And finally, we ask the user to clean up the sample, and the rheometer head moves up to the loading gap. We say OK. And it brings them right back to where they started, which is the one-touch interface. So this script highlights how we can use step-by-step guided operation. Load in pass-fail values, or you could even prompt the user for pass-fail values before the test starts. Or you could build in decision-making where you can take the results from one test and use it as an input for the next test, or do a different set of tests and so on. So there's a lot of possibilities here. The next use case we look at is in a shared analytical lab. So a shared user facility is usually open to operators from different departments and groups. There's a primary owner, but it's usually, and all of these can add barriers to the speed at which the data can be collected by a new user. It also limits the rate of instrument utilization. And through autopilot, we will see how we can walk a user through all of these different steps that are involved in running the instrument from start to finish. So in this case, this lab is set it up with different options, including geometry calibration, instrument verification, viscosity curve measurement, yield stress, exotropy, strain sweep frequency. Playing the video now. The specific example we will look at is for viscosity measurement. Once again, the user starts it with from the one-touch interface. We give them an overview of what the script will be doing. And then we ask them to verify the geometry is already installed. Once they say OK, we ask them for the test temperature. The instrument then waits to get to that temperature is 25 degrees in this condition. And once it gets there, it's going to wait and soak at that test temperature for a few minutes. And this is important because you want to make sure that the geometry has equilibrated at the test temperature before you do any additional calibrations like a zero gap. And this is particularly important when you test at high temperatures, when you're doing polymer melts. You might be testing at 180, 190 degrees, and you want to ensure that the geometry, we can go through and do the zero gap calibration. You can see the gap decreasing. So that happens. And so again, notice that the user does not have to press anything on the instrument keypad or within TRIOS itself. All of this happens. It's completely guided through the autopilot interface. Once the gap is zeroed, they click OK to continue. This particular this particular user is testing a purple hand soap. They enter the sample information, operator initials or name, and then we give them an opportunity to review the test parameters. And it's important because in the shared use facility, we start with a general set of parameters that works for most users, but then we give them the option to change this as needed. And then we notice that the shear rate, the final shear rate specifically, changed based on the input in the dialog box. So the user has an opportunity to override specific parameters through instrument operation through video playback that shows them how to load a sample. And again, notice how the rest of the UI is grayed out. So there is no other opportunity to change other parameters in the test except for what was presented in that dialog box. So once the sample is loaded, we click OK, and it moves to the trim gap. And once it's at the trim gap, we will again pop up a video to walk them through how to trim the sample correctly. So you need to start over. So there are a lot of checkpoints that we can build in to guide new users to effective instrument operation. Right, users trimming the sample right now. They click OK. And now we always ask them to verify that the sample is loaded correctly. So it's good to have this check. They say yes. They say no. And now we're on our way. So this test is going to run. We first soak at, we'll have a temperature soak as part of the TRIOS test procedure. And after that, we'll start seeing data points populate on the screen. So this particular example in this use case, we've shown how videos can be used for guiding users through sample loading and trimming, but the same concept can be extended to other aspects as well. For example, you can show them how to install a geometry. You can show them, if your specific sample has, and at the end of this, once the test is complete, we will automatically do an analysis and bring them back to the one-touch view. So again, they started the one-touch view. When they click OK, after cleaning the sample, that is where they will be brought back to guided operation with a simplified interface. And that is the goal of autopilot. First example we will see will be for automated data analysis on a set of files. Before we start the video playback, you can get a quick peek at the autopilot code that makes this functionality possible. So it's designed to be a very simple interface. It's block-based programming, so to speak, and you have blocks that correspond to different TRIOS functions. And the goal here is to make it easy for even non-programmers to write scripts. And we'll take a closer look at some of this in the following slides. But the script editor mode, where you can change the script as needed, but you can also launch the same thing from a dedicated autopilot button on the TRIOS ribbon. This script will ask the user to select a folder that has all of the files to analyze. And so once that folder is selected, each of the files inside that folder is going to be opened. We will look at the frequency sweep file. We'll do an analysis, which is a modulus crossover. And the analysis being done, enter the control chart, the file is being closed. And we keep repeating this for all of the files that are in that folder. Now we'll speed up. That particular folder had about 80 different files, and all the user had to do is to hit start and select the folder. From that point on, it is truly in autopilot mode, where it's opening each of these files, doing the analysis, and sending it to the control chart and populating that without any additional inputs from the user. Part that has the data from the minimum, maximum, and the file that matches most closely to the average. And so these are saved as individual files. And let's say you want to generate confidence limits, tolerance limits based on historical data. you could do this and then identify the band that you want to set up as pass-fail limits. That's just one example where autopilot could be used. So there's a lot of flexibility and versatility that's just built into autopilot in terms of post-processing analysis. So autopilot allows you to easily automate TRIOS operations and rheometer operations. And it's aimed at analytical lab managers and research scientists who may or may not have a background in programming. And so we recognize that, and so to help with the functionality, we've built in several features that will make it easy for you to get started and to use autopilot. The first is a comprehensive suite of fully functional example scripts for common operations, and these pieces to suit your requirements. And some of these example scripts include instrument and geometry calibration, running a test from start to finish in the form of instrument verification. You can just swap out that instrument verification procedure with your procedure and it's good to go. Opening and exporting a batch of data files to other formats, including Excel, text, or just like the example we saw, performing the same set of analysis on a set of files. Building blocks in the form of pre-configured sets for the most common actions in the form of express scripts and quick steps. And the whole interface itself is based on Blockly from Google. Simply just drag and drop color-coded blocks, and you can start assembling powerful functionality really quickly. And if you want to see this in action, the drag-drop functionality, just go to the TRIOS AutoPilot page on the TA Instruments website, and you can access that from the folder in the lower right corner. File operations, loading and running experiments, data analysis, report generation, and you can also automate instrument actions, being able to control the gap and the temperature, check for the date of the last calibration if needed. You do the calibration within the autopilot routine. You also have access to additional functions that are not present in TRIOS, like video prompts, audio prompts, countdown timers, and so on. And all of these are coupled with programming blocks that allows very powerful functionality that's easy to access even for users without a programming background. And if you need additional help, we have resources from our software group ready to assist you. So you can choose from fee-based script writing where TA can write the script for you, or you can have remote or on-site consultation with TA experts to train you and other users within your organization that need to write scripts. Challenges that are commonly encountered in analytical labs, whether it's SOP compliance, operator training, or advanced calculations. For SOPs, you can now convert written SOPs into automated scripts, assuring full compliance by minimizing scope for misinterpretation. You codify all of that institutional knowledge that advanced operators have. You can minimize operator training essentially through guided operation, through videos and text-based prompts. And you can now integrate advanced analysis that was previously done in third. And with that, I thank you for attending this webinar. Over the next week or so, look out for an email from TA that offers all the webinar attendees a special invitation to try out autopilot for free in your lab. And thanks again for your attention, and I'm happy to answer any questions.
First, thank you, Bharath, for the great presentation. We will now answer some questions that were submitted. This webinar will be archived and on our website. With that, I will start the questions that we have. The first question that we have, Bharath, comes in and says, is there a plan to add this to existing Aries rheometers running on TRIOS? And if yes, by when?
Yes, we do have a plan to bring out autopilot to other instruments, including our suite of thermal instruments. The feature itself is to make sure we address the right features going forward. The goal is to bring all TA instruments, rheometers and thermal analyzers, on the autopilot platform within the next year or so. And Jeff can add additional comments on the timeline.
Yeah, we are currently, the goal is for us to move all instruments that currently run in TRIOS into autopilot. That is, how is the video recorded? Is a camera included with the as a software option?
Video is not recorded through TRIOS, so you could record a video on your cell phone, and you could just reference that video file through the autopilot script. So we're not directly recording videos through the rheometer in this instance of autopilot. Now, if you do want to record videos during your rheometer experiment, we do have cameras, meaning you can just record any video and you call that from within autopilot.
Okay, the next question is, does the autopilot functionality come at an additional cost?
Yes, there is an additional cost. It is a premium feature. It's a one-time fee, and it's licensed per instrument. So if you have 5 rheometers in your lab, for example, you would need to get this per instrument.
Yeah, one thing I would like to include with that is any offline functionality where you're programming to do analysis of your results. You can put that on as many PCs as you like. So if you have a single license for autopilot because you have one instrument, you can use that on as many PCs as you want to be able to do offline or online to that particular instrument. All right. With the next, does this have to be done in batches of files, or is there a way to do that at the end of every test?
So the specific example that's a good question. So the specific example that I showed was to analyze historical data, but it can be integrated into the script itself. So as soon as you finish a test, you can just simply send the analysis results to that control chart. So you're doing this on a continuing basis. Go in here that says we have a LIMS system that tracks data across multiple instruments in our lab. It requires data in the XML format. Is it possible to do that through the software? Oh, that's an excellent question, because yes, one of the example templates that ships with autopilot shows, and I will jump back to that slide, allows you to export files to, and autopilot is external support for advanced, for other LIMS systems. So that is built in. You would just need to make a simple change in that script and you should be good to go. And I'm also going to bring Jeff into this conversation because he has extensive experience with integrating with LIMS systems.
Yeah, actually, so we do have a lot of customers that have requested this very same thing, and in some cases they want the data formatted in specific ways to go out to and populates it. So anything that you can put inside of your data file can be put into a text file via autopilot in any format. So if you wanted to only include a couple of your signals with that, or maybe you're interested in just the average of some of the values or the results of an analysis that you're putting on there, you do have the ability to be able to custom format that any way you want. So XML in this particular case, you put those tags out in a way that the LIMS system would recognize immediately and be able to pull in. So that was a great question. Thanks for asking that. We have another question here that says, does autopilot allow advanced functionality such as analyzing results of one test and then feeding the results into another test to be run in sequence?
Yes, in fact, that is one of the, so because autopilot examples on how you can override parameters in a test procedure based on user input through a dialog box, that same thing could be done programmatically. So you could say, I've finished my strain sweep, and here's an excellent example for rheology. You could do a strain sweep, and you could look at a strain where the value starts to, the modulus starts to deviate by, say, more than 5 or 10%. And you could say, I want to pick a strain that is inside the linear, it's going to be my frequency sweep. And you could build in additional smarts too. So you could say, all right, I just finished a strain sweep. Let me repeat that strain sweep and see if that modulus value has recovered, or do a time sweep to see if the structure is recovered. And you could say, right, this is recovered, so you can now continue, click OK to continue with a frequency sweep. Or you could say, the sample appears to have been destroyed by the strain sweep test, linear viscoelastic region test. It's recommended possibilities in terms of what can be done through the functionality that's built into autopilot. That's an excellent question.
Excellent. So I have another question here that's similar to what you just answered, which is you briefly mentioned that autopilot can handle conditional decision making. Can you provide some examples of how this would be used in a lab setting?
Right. Essentially, that is what I just described right now, where you could go from a strain sweep, take that back to a frequency sweep for subsequent testing.
Great. All right, I have one last question here, which is our lab tests many products, and the test methods are product specific. Can the software accommodate different methods?
Absolutely, it can, because if you look at the one-touch interface, you can have individual scripts and script buttons for different products. So you could set this up by click, select that product, and they'd be on their way. They don't need to, they don't need additional involved inputs from the operator to be able to use that within the autopilot framework.
Excellent. Well, with that, I will unfortunately have to bring the question and answer session to a close. Any additional questions that we didn't answer, we will answer by email as soon as possible. Thank you, and have a great day.